We'll proceed in primitive calculus. So primitive calculus in sense that how calculus evolved. How calculus evolved. Why are we using a calculus? Okay, so like I have a I have a kind of I have a pen. I have a pen. I have a pen. And if I have a pen, then through pen I can write it. But I'm not writing. I have a pen. Can you see my pen? Pen, it looks so beautiful. The pen looks so beautiful. I have a pen. Everywhere I'm going and saying, I have a pen and it looks so beautiful. Anyone will say, but if you use it, if you write something, then it will look more beautiful. It looks beautiful, it's true. Okay, beautiful in the sense if you are not using it, it is as good as it is an item which is has blue color and then black color, then again blue color and then blue color and some steel or iron looks like. It's beautiful. But if you start using it, writing it, then actual beauty would come. Same thing is the algebra. Algebra looks very beautiful. Algebra looks very beautiful. But when someone start using algebra through calculus, then algebra really looks beautiful. Primitive calculus. Primitive calculus, like when we started using the algebra. If you see the history of petroleum, there is a place, there is a place in Azerbaijan called Baku. Baku is a place in Azerbaijan and is a, I believe it's a capital of Azerbaijan, Baku. So in Baku, there is a place called Ramnan. Ramnan. So in Ramnan, the petroleum liquid that used to come from the land, like water comes out. Many places you'll see from land, water stream comes out naturally. Okay, so petroleum water, that liquid, is to come out from the land. So Baku used to earlier the petroleum that was used as a kind of a normal fuel, okay, or in lantern and those places means kerosene was used. Either you use it to ignite a fuel, okay, in villages, or you put in goitha or you put in kind of goitha is cow dung dry up to kind of start the uh, fire, or in a wood you can put it and then it can start the fire. That is the reason, that is what it was used for earlier. Okay, petroleum has been it is in use since history only. When it is coming out of the earth, when petrol is coming out of the earth, and if you put match, okay, fire, it will catch fire immediately. That's why there is a fire temple also in Baku. There is a fire temple in Baku, though it is a Muslim place, but still Sanskrit and temple is there, fire temple, because it catches fire. But later, people said that the real use of petroleum is not that you use in lantern or you use to ignite a fire. The real use is much more. And then automobile sector, actually, the actual use of the petroleum product is actually it is in automobile, where there is no alternative. Okay, there it has the actual use. You can generate electricity where there is no alternative. I'm not saying as a fuel because it is killing the actual fuel, but whatever it is. That way, if I talk about algebra, then it is better used when it is in term of calculus. Okay, so calculus is automobile mobile sector which is using algebra. If I consider algebra as raw material. Okay, anyway. So if that is the case, then where are we? Where we started? So now we have what we have seen is that if we are doing addition, then there are three branches in the addition. One branch is addition, another branch is multiplication and of calculating the addition, and third branch is addition can be calculated through area through area. So, what is area? Addition is nothing but if I keep adding, indirectly there are two components. One is that what is the rate? Keep adding. Addition means keep adding, keep adding, keep adding. Okay, but beside that, it is not that simple. If I say I add two, then someone will say 5 times. So the independent variable is 5 times. Or I can say 2 I added in 5 hours. Every hour I added 2, then 2, then 2, then 2. Then independent component is hour. Means how I can proceed. The idea is that we have seen in the last session that if I go for addition, as far as addition is concerned, through addition and multiplication, then there is limitation. There is limitation. We cannot go beyond a level. But if we calculate addition through calculating the area of a shape, area of a shape, calculating the addition through area of a shape, then it is more way we can go. So if I take third part in addition, first part addition, multiplication, and third is calculating through area. That portion in that branch, then two big guys come into the picture, that is algebra, and then on top of algebra, calculus. So the third branch, that is the area branch through which we are calculating the addition. So addition through area, we also call it calculus or integral calculus. So if calculus is one domain and numeric science is one domain, then addition is base of numeric science. Then for calculus, integration is base of the calculus. Okay, addition has many way to calculate the addition. Three way I am saying, there can be other way also, but calculating the addition through calculation of area, that branch comes in calculus, not the multiplication and addition. So that branch comes in calculus. Okay, now when it comes to calculus, then there comes as algebra. If comes to algebra, then there comes two components. If I am talking about 2D, one is called independent component and one is called dependent component. If I am saying that I am getting 2 oranges every hour, 2 oranges every hour, or I am walking 2 kilometers every hour. So 1 hour, if I go and see how many kilometers I have walked, 2 kilometers. Again, I walk for next 1 hour, 1 hour, and see how much kilometer I have collected in this hour, then 2 kilometers. Now the independent component is hour and dependent component is algebraic equation, that is if hour is t, then there is another guy called function over t. This is the way algebra works. So function over t. Function over t is 2. 2 is constant. So if this is x-axis, or time axis, then there is a vertical orthogonal to it. If this is time axis, there is orthogonal to it called function over t. If it is function over t, if this is t, then there is a function over t, then that function over t is equal to 2. 2 is constant. If that is true, then at height of 2, there is a line I can draw. This is time axis, and then height of 2, there is a parallel line I can draw, that is 2. So I can say the function over t is 2. Now I have to calculate addition. If 2 kilometer per hour person is walking, at the end of 25 at the end of 25 hours, no one can walk that much. At the end of 25 hours, how many kilometers he has walked? Means how many kilometers he has collected. So that is now 2 is the height and base is 25. 25 into height is it forms a rectangle. Can you see? 25 is the length or width, whatever you say, and uh, and 2 is the height. If I cover it, it becomes a rectangle. What is the area of the rectangle? 25 into 2. Same thing. How many kilometers he has walked? 2 into 25. That is nothing but area of the rectangle. If I show the 2 kilometer per hour as a algebraic equation, 2 means height 2. And in orthogonal, if t is the x-axis, then orthogonal to it is y-axis. In y-axis, if I show 2, then 2 is the height. Now, how many kilometers he walked? So, 25 into 2. But algebra is algebra. Everything must be in algebra. 2 cannot be algebra. It's a numeric. So, actually it is t into t to the power 0. Okay. So, function over t, the kilometer per hour he is walking. So, if I call this as ft, function over t, that is nothing but 2 into t to the power 0. It's an algebraic equation. 2 into t to the power 0. Then how much kilometer he has walked is the area. But now calculus comes into the picture. It is not the area, it is integration. So integration of a algebraic equation 2 into t to the power 0 along t-axis, x-axis. These are the fancy words. If anyone asks how much kilometer he has walked, anyone will say 25 into 2. That's it, multiplication. But if you go into area, there you are coming in clutch of calculus and algebra, where there is one independent component, one dependent component. Dependent component is function over independent component, and now it is ft. Person is not walking 2 kilometers, it is walking 2 into t to the power 0. That is algebraic equation. Now, if we want the net in now, you are talking about calculating the rectangle area, but in calculus you are talking about integration of t to the power 2 into t to the power 0. At the end you have to calculate the area. So area of t into 2 into t to the power 0, the integration is 2 into t to the power 0 plus 1 divided by 1. So 2t. So 2t is the area. Now area is again algebraic equation. The line, the collection, the kilometer per hour, that is the collection. If that collection is algebraic equation 2 into t to the power 0, then area or net collection, net kilometer he walked, again it is algebraic equation 2 into t. If it is 2 into t, keep varying the t and you get the how many kilometer he has walked. This is algebra. So calculus uses algebra. So calculus is an engine which take algebraic equation and it passes through calculus engine or filter, and then it gives output as an algebraic equation. So algebraic equation passes through calculus and then it gives another algebraic equation. Input, output. In between there is a circuit. So circuit changes input to output. Both are algebraic equations. 2 into t to the power 0 converted into 2 into t. 2 into t is the area. That is the net collection. If you have collection per hour, then integration will convert into collection. So collection is nothing but 2t. If t is 1, then he walked 2 kilometers. If t is 24, then he walked 48 kilometers. If t is 10, then he walked 20 kilometers. So I can draw 2t graph also. If I have a graph t 2 into t to the power 0, that is a straight line parallel to x-axis, then I can, no one stops us drawing graph of 2t. 2t will start from origin. If this is x-axis, this is y-axis, this is origin, then from origin there will be a slant line will come which will have a slope angle, and that is 2t. Okay, so 2t is the now new algebraic equation came, and now that is the net collection. So this flat line is collection per hour, whereas this slant line is new area curve, that is net collection. Amazing, right? But we have to do this much when you are in. Now someone was saying I was calculating simple addition through addition and multiplication. Why you brought this big a story to it is required? That also we talk. So suppose that person is walking at a speed of 2 kilometers per hour. Now person is walking at a speed of t. At any moment his speed is changing. He is doing like that. Okay, like he from home he started to buy something. Okay, he is in hurry, he's keep on watching his watch, and every time he is feeling that it is that he is kind of delaying, it should be fast. So his speed is growing, his speed is growing because he do not have he does not have the time. Okay, so if that is the case, then his speed is t. Every moment his speed is growing. So when t is 0, when he started from the rest. But slowly he started feeling that he is delaying. So he is when he is quarter hour, 0.25 hour, at that moment his speed is 0.25 kilometer per hour. When at the end of 1 hour, at that moment t is 1 hour, at that moment its speed is 1 kilometer per hour. When it is 1.5 hour, then speed is 1.5 kilometer per hour. Its speed is changing. If that is the case, now speed graph is t. Earlier the area graph was t. Now speed graph is t. If speed graph is t, then at the end of 2.5 hours, how much kilometer he has walked? You cannot calculate through multiplication. You cannot calculate through simple addition. Now the people who were laughing at you, that why you are doing this much independent component, dependent component. Now you can ask them, can you now calculate the net addition? That how much kilometer he walked at the end of 2.5 kilometer hour? No one can answer. Now, since we took away that addition is nothing but calculation of the area, now if this is a triangle, if independent component is t and dependent component is function over t, that is t to the power 1, then what would be the integration? Now we learned that if it is t to the power 0, then integration is t. If t to the power 1, then what is the integration? Okay, because mathematician will go for generic thing. They will not go for one solution or another solution. They will try to find out formulae. So now people will say that 2 kilometer per hour, 25 hour, 50 kilometer. But mathematician will not be satisfied with it. They will try to find out some formula. So they will say 2 into t to the power 0, it become 2 into t to the power 1. Okay, with net multiplication. Now if it is t to the power 1, then if it is a triangle, at the end of 2.5 hours, if I see, at the end the width is 2.5, so height is also 2.5. So triangle is half of the rectangle it forms, then it is 2.5 into 2.5 divided by 2, or if I say at the end of 3 hours, then 3 into 3 divided by 2, that is 4.5 kilometer he has walked. But okay, so if it is t, then height is t, and t, then area is t square by 2. Now if it is t0, then integration is t. If it is t to the power 1, then integration is t square by 2. This is what we saw, right? This proves that integration of t to the power n is t to the power n plus 1 by 2 by n plus 1. This is integration. This is how slowly people started the calculus fundamental. If I, whatever the calculation I have to do, the addition I have to do, if I consider this a function over an independent component, If this is function over an independent component, then independent component, if I draw along a axis, and function over independent I draw as a curve, and I take two limit and calculate the area, then I am calculating the net addition. So if it is a triangle, then net addition is the area of the triangle. If it is a sine curve, if it is sine t also starts from 0. It goes till maximum 1, then come back to 0. Okay. If it is sine t, then what is the area? If someone say integration of sine t is minus cos t, if integration of sine t is minus cos t, this proves that that is the area. Integration, if sine curve is there, 0 to pi by 2. A person is working with a sine curve. Okay, to start from 0, and he starts working until pi by 2, radian pi by 2, how many kilometer he has walked. Okay, so integration of sine t, if I say, I will talk. If it is minus cos t, so minus cos t, and then from 0 to pi by 2. Cos pi by 2 is 0, and cos 0 is 1. So minus will go away. So answer is 1 kilometer he has walked. Okay. So the fundamental here is how primitive, how calculus equations evolved. Now we know that, now we nicely know that if the function, what we are trying to do is, if I have a problem, if I have rate of change like kilometer per hour, it is rate of change, kilometer per hour. How many kilometer is how, if there is a change in 1 hour, if in time there is change in 1 hour, then how many kilometer change that person is showing? That is kilometer per hour. If kilometer per hour rate of collection, rate of collection, if it is through algebraic equation, then what is the net collection? That if that is the case, then we can find the net collection through calculating the area. If that is the case, if net collection is through calculation of the area, then we call it integral calculus, where independent component is 1, the dependent component is algebraic equation, and for that algebraic equation, rather than calculating the area, we have some basic area already known. If it is a rectangle, then it is t to the power 0, then it will be t. If it is a triangle, then it is t to the power 1, then it will be t square by 2. Then if there is any function over t, that is t to the power something, then it will be something means n, then it will be t to the power n plus 1 by n plus 1. If there are addition, then integration will happen with the addition. If there is a multiplication, then if it is x into y, okay, then there are rules, chain rule, whatever. This is slowly, it start getting evolved. Okay. Now, if consider that if I have a function ft, ft is nothing but rate of collection. What we get, if this is calculus, integral calculus, if it is integral calculus, and this is the input, if this is the input, that is algebra, it passes through integral calculus and transforms and becomes another algebraic equation. If this is fx or ft and it passes through integral calculus and it becomes gx, fx, after integration it becomes gx. Okay, then gx is called anti-derivative. Integration is also called anti-derivative. Means if fx integration is gx, then if I do derivative of gx, then it will become fx. Okay, if I have 5 oranges, I collect 10 times. 5 oranges I collect 10 times. That is 5 into 10. 5, 5, 5, 5, 5, 10 times. 5 into 10. It is called multiplication. 5 into 10. Then what is division? Division is also multiplication. 5 by 10. 5 by 10 is not correct word. 5 into 1 by 10. That is correct. Everything is addition, then everything is multiplication. Division comes at the layer of multiplication. 5 into 10 equal to 5 into 1 by 5 by 10. Wrong word. Like 5 plus 2. Correct. 5 minus 2. Wrong word. 5 plus minus 2. That is correct word. 5 into 5 by 10. Not correct. 5 into 1 by 10. If I say 5 into 10, then 5 item I am collecting 10 times. 5 into 1 by 10 means 5 item I am collecting 1 by 10 times. How someone can collect 5 item? If say 5 item I am collecting 1 time, makes sense. 5 item I am collecting 1 by 10 times, then it is going away from me. So if multiplication is collecting, then division is collecting, but direction is reverse. So if I say 5 by 10 means I have 5 items, but I am giving 10 times to someone. How it's possible? Means 0.5 times 0.5, 0.5, 0.5. If I give 10 times, then it becomes 5 by 10. Means 5 item I have to give someone 10 times. Okay, or if I have 5, or if I receive 0.5 item 10 times, then it becomes 5. Same thing, right? So if I have kind of, if I say that, just think in reverse fashion. If I have something that is 5, 5, 5 into 10 is how much? I don't know. 5 into 10 is how much? I don't know. Can you find a number which is distributed 10 times? If I have a number x and 10 times if I give someone that x, then x is over. 5 into 10 is how much? 5 into 10 is x. What is x is, if x I cut into 10 times and at 10 times I give it to someone, then it will be over. That is x. So out of all the numbers, I have to find a number. I have to find a number which if I divide into 10 times, then it becomes 5. 5 into 10 is how much? So out of all the number, you try to find a number which I cut into 10 parts and give someone 10 times, then each time I will give 5. That is the 5 into, that is the that is the amount, that is 50. If 50, if I cut into 10 parts, divide by into 10 parts, and every time if I give that amount is 5, that is 5. 5 into 10 is how much? That is a number which I divide 10 times, then every amount will be 5. That is the number, that is 50. Okay, so this is called NT division. NT division. Multiplication is nothing but NT division. If I have a number and if I divide it 10 times, and whatever the amount comes, that amount, if that this is what I am trying to do multiplication, that is the amount. So that is nothing but 50. 5 into 10 equal to 50, because 50 is an amount which I divide 10 times, then it becomes 5. Similarly, if I have a function fx for which if I do integration and it becomes gx, then gx, if I do derivation, there is a new term came into the picture, that is called derivative. Division, derivative. Okay, what is derivative? We will talk more on it. What is derivative? Now consider that I have x-axis, that is x-axis, that is x, and y-axis, function over x, y-axis, is 2, that is constant, 2 into x to the power 0. If I calculate integration of it, then it becomes 2x. There is a function called 2 or 2 into x to the power 0. If I pass it through integral calculus, it becomes 2x. From 2x, can I get back to how? If it is fx, there is an integral. If it passes through integration and it becomes gx, fx, if it is integrated, it passes through integral calculus, it becomes gx. If I have gx, then how I can get back fx? That is the question. So if I have someone says I have integral value is k into x, then what is if this is gx? After integration it becomes gx, then gx equal to 2x. Then what is the actual fx? Function, I have a function. I have a function that I don't know. If I do integration, it becomes 2x. From 2x, can I say what was the function for which this is the integration? That is called antiderivative. Anyway, so very simple question. If I have a function called 2x and this function came into the picture because there is a function, I don't know what it is. If I do integration of that function, then net resultant function is 2x. Then someone would say if it passed through integration means someone has calculated the area. If 2x is the area, then divide by the width. What was the width? Width is x. 2x by x. That is 2. 2 is the height. That is the function. Integration is nothing but calculation of the area. If someone says that I have a function called 2x, means x is variable. X is variable. Then what is the function that was integrated to generate 2x? If that is the case, then 2x is the area of something. If it is area of something, x is variable, that is x-axis. If I divide, if it is area, then there are two sides. If there is an area, then there has to be two sides to of it. If x is one side, then what is other side? 2x by 2. 2x by x, then 2. 2 is the initial function, that is fx. Fx is 2, then after integration it becomes gx, that is 2x. If I say the integration is, now it is simple, right? Means I just divide it and get the one side. One side is x, then other side is 2. Antiderivative is easy. Means if I, so whatever the reverse we are thinking, this is called derivation. This is called derivation. Okay, I mean antiderivative is this one. This is called derivation. If I, okay, so this is gx, we can call it antiderivative also of fx. If gx is there, if I try to find fx from gx, this is called differentiation. Integration, differentiation. If I have a function and if I pass it, if you do integration at results in another function, then that function, if I try to get back this function, the procedure that passes through is called differentiation. If I have 5 into 10 equal to 50, the procedure it passes through to get back the 5 into 10 multiplication equal to 50, then what is the procedure that it will pass through to get back to the 5 is division. If this is multiplication, 5 into 10 is 50 is multiplication, then 50 by 10 is 5. This is called division to get back the initial amount. If 2 becomes 2x as integration, then from 2x, if I do differentiation, it comes back as 2. So this is another term came to get back the integration function again. So if I have rate of change, if 2 km per hour someone is walking and he walks 50 km, then what is the rate of what is his speed? If someone says that he is walking 50 km, then what is his speed? Anyone would ask that how many hours? He will say 25 hours. Then 50 is area. If 50 km he has walked, That is the area. How many hours he worked? Actually, he's trying to find the independent component. If independent component is 50, then 50 is 25, then 50 by 25, that is the dependent component he is getting, that is 2. So if I have rate of collection, if I do integration, I get the net collection. If I have net collection, then if I want to get the rate of collection back, then I have to pass it through another procedure, that is differentiation. Differentiation is nothing but, if I have an area, integration is nothing but calculation of an area. Area has two sides. If I divide by one side, I get back the algebraic equation. The algebraic equation 2, I know now. If integration is 2x, then independent component is x, then 2x by x, that is area I have, then width if I divide, then height automatically I get back, that is 2. Now consider that the fx, the function for which we are calculating the integration, is x. If function is x, then integration is x square by 2. If someone asks that integration is x square by 2, integration is x square by 2, then what is the actual function? Gx is x square by 2, then what is fx? Means gx is an area. If there is area, then there are two sides. What is independent? Independent component is x. At any moment it is x by 2, x square by 2. If that is the case, then x square by 2 by x is the function. So that is x by 2. But that is not true. The function is x, and for that integration is x square by 2. If I do simple division, x square by 2, then it becomes x by 2. That is not the function x. So differentiation is more advanced. If 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 integration is more advanced to multiplication, then differentiation is more advanced to division, because division happens on numerical numbers. Multiplication happens on numerical numbers, but integration happens on algebra. Differentiation happens on algebra. Algebra is nothing but which produces number, but number keep changing based upon the independent component. So algebra is a science which has an equation, but equation has whatever the variable we see in the equation, algebraic equation, those variables are called independent variable. If I keep changing independent variable, algebraic equation will keep giving different values, whereas any numeric is constant. So if it is variable, keep changing as upon the independent component x, then we have to use another way. If it is a number, then I can do multiplication. But if it is algebraic number, there is one called numeric number. If it is a numeric number, then I can do multiplication. But if it is an algebraic number, then I have to do area, that is integration. Algebraic number, integration. Numeric number, multiplication. If I have fx, if I do integration, it becomes gx. Then if if from gx I want to get fx, then rather than doing division, now I would do differentiation. Integration, and then back if I want to get, then differentiation. Okay, why these are the scenario comes into the picture? Because algebraic equation is not the static. It keeps changing based upon the independent component. Okay, so that is the concept, that if I have a kind of, if I have a function, and that function if I calculate the area, then if it function is fx, then area is nothing but gx. But from gx, if I want function back, then I cannot divide simply the width. I have to do differentiation to get this. Is also called, this is, so it is also called anti-derivative. If I try to find integration of some, so one way people also see that gx, if I have function fx, integration of fx is gx, then then differentiation of gx is fx dgx by dx. This is the notation. If I have integration of fx, then I have to place a snake symbol fx dx. So we call it fx dx is gx with a snake. Then here dgx by dx, it's a kind of similar to similar to division. dgx by dx, then that is fx. These are the symbol. Generally, people, I believe snake was enough, but people put dx there because fx into width, fx into width is the area. fx dx, fx dx, fx into dx is the area, two components. If there is an area, there has to be two components. fx dx, if you multiply, it becomes area, that is fx dx, that is gx. Now gx, if I divide it by x, gx, earlier it was 2, it became 2x. 2x, if I divide it by x, it becomes 2. Gx, dgx by dx divide by x. Understand, right? So dgx, d we are putting there to make people believe that it is calculus. Otherwise, it is gx by x. There, d I have put, otherwise it is fx into x. fx is 2. If it is a constant, then 2 into x. That is integration. fx into x, d I put so that it looks like calculus. So fx dx, multiplication. This is multiplication. Becomes area, and that is gx. Gx by x, division, it becomes fx back. Now it is calculus, so dgx by dx. Okay, then this is so integration is also called antiderivative. Antiderivative, if I have to calculate from fx to gx, then we imagine some gx out of all the algebraic functions possible in the world. I try to find a gx for which derivative is fx. If for gx, if I do derivative, it becomes fx. Then for fx, the antiderivative is gx. So to find the integration, generally people do antiderivative. Okay, they kind of imagine something for which the derivative is fx. This is also a way to calculate the integration. Understood, right? To from addition we started to add something, then there is a way to calculate the area. If area comes into the picture, then algebraic equation comes into the picture. If there is algebraic equation comes into the picture, then independent component and dependent component, two things comes into the picture. Then there is a function. If there is an independent component, dependent component, then dependent component is nothing but a function over independent component. Then it makes a independent component is a line, then dependent component function is a curve. If I calculate the area, that is the addition. That is nothing but if it is fx, curve is fx, that is vertical, and this is horizontal is x, then fx into x is the area. But since it is not constant, so I cannot do fx into x. Rather than I can say fx into dx. That is the calculus. Now if it generates gx, then if I divide gx by the width, it should come to fx, but it is not the case because it is not the straight line, or it says not a straight line. Gx is not a straight line. So dgx by dx, that is calculus, that is differential. We will move more on it, and we will see that how things are now. Things are kind of little hazy. So how it will become straight, and then our life will be really easy as far as we enter into a arena of calculus and algebra, because things are different at different moments. That where addition and multiplication, division, subtraction, all are failing. So that we will see.